URL means Uniform Resource Locator, and it is a way to indicate a page or document request. A URL is composed of various portions. I have indicated here somewhat symbolically. There is a scheme that for us will be always HTTP or HTTPS for the web. A host name with an optional port. When you're connecting to your local laptop, it's gonna be typically 8000 or 8080. Then there is a path portion that looks like essentially a path in a directory separated with slashes. Then a query portion preceded by a question mark and a fragment. We won't be using fragments often in Py4Web. In Py4Web, we will want to generate all URLs using the Py4Web URL helper. This will enable us to move our code from one application name to the other, because we have to remember that in Py4Web, the path portion, this portion of the path, is composed generally of the application name, then of our particular endpoint, and then of the rest of the path, right? And we don't want to ever to hardcode the app name, because the app name is simply the name of your application inside the app folder, okay? So I want to show you how it works. I can actually do it in this way. So I want to show you how to generate URLs using Py4Web. I can do it by doing IPython. This is an interactive Python shell. I can import Py4Web. Then from Py4Web, I can import the URL helper. Okay, and now I can build URLs. They will be missing the app name, but they will contain the rest. So the simplest way you build a URL in Py4Web is by saying URL, in which you say your endpoint. For example, you can say index. And this will generate the URL index. You can also say URL of index, and maybe you have some parameters. For example, you have the record ID, which is 34, and the action to be done, that could be edit. And this will generate a URL in which these components, index, 34, and edit, are joined by slashes. Okay? So in general, this will be the endpoint, and the other two will be parameters for the endpoint to know what to do. And in the endpoint, you could define essentially an action in which you say that this is index, and then you can say record ID, which is an integer, and then you can say action type. Okay, and so that's how you declare something that can receive this type of URL. Okay, so this is how you generate the path in Py4Web. And if you want to generate a query string, you do this URL, for example, index 34, and then you say variables to be encoded is equal to a dictionary in which A is equal to 23 and B is equal to dog. Okay, so if you generate a URL in this way, index and 34 become part of the path, and A is equal to 23 and B is equal to dog become part of the query string. This also takes care of encoding any characters that cannot directly take part in a URL. For example, if you say dog and cat, here there is a space character that needs to be encoded, and the URL facility of Py4Web takes care of encoding it. You see it has become this %20, which is the encoding of a space. Another important thing that the URL generator does is it allows you to sign the URLs. To see these in action, we have to import the URL signer. So from py4web.utils.url signer, import URL signer. Okay, And then you have to build a URL signer. This is a class, you have to build an object of that class. Normally you can just build it with passing the session as an argument, but in this case, because we are not in an actual web server, I'm simply importing the modules, I will need to give it a key. So I say signer is equal to URL signer of key is equal to, and here I specify a secret string explicitly, so my secret key string. Okay, and this will build a signer, and then I can take exactly the command before this one and specify a signer. Signer is equal to signer, and this will sign the URL. This means essentially that this portion of the URL, not any variables, but the path portion of the URL, not the query string, is signed according to the secret string, and the signature is this one. The signature comprises not only this path portion, but also the timestamp, so that you can verify when the URL is then used, how old you allow the URL to be in order to be still valid, the signature. Okay, so the signature can also have an expiry time that you can specify. There is a way to specify which portion of a URL should be signed. Normally it's only the path, but if you wish, you can also include some of the variables in the signature. I want to tell you more in detail what is the purpose of signatures and how they work. Imagine I give you a web page in which you can manage your mechanic reservations, and there is a page that says this is your reservation, etc. And among the various options you can delete it, and this particular URL to delete it will look like delete, and then there will be the reservation ID of your reservation, which might be 17. Okay, now this URL is problematic for two reasons. One is that you can modify these into perhaps 18, so that you don't delete your reservation, but you delete a reservation with ID 18 that might belong to somebody else. This is the first type of attack. The second type of attack, you have seen it in a lecture on attacks in the past, and that is somebody builds another page in which the question to you is, would you like $1,000? And the button that says yes contains delete 17, so that they essentially fool you into clicking on that button that will be send this URL to the server, and that the URL will result in the deletion of your car fix-up reservation. So how do you prevent these two types of attacks? You prevent these via signatures. So let me make a distinction between the information that is on the browser, in the browser. Okay, so this portion here is in the browser, and this portion below is on the server, in the session. Okay, so in the session we will be writing our secret signing key. Okay, the signing key is simply a random string that is different for every user. The first time the user asks to sign a URL, the server will produce a random string in a cryptographically safe random way, and it will store it in the session. Okay, and what is important really is that this portion of information here is not visible to the user. Okay, so the user cannot guess the content of the session. So what happens then when you ask this URL delete 17 to be signed? Well, what happens is that there will be a question mark and a signature, which is equal to a signature S. I simply write S for the signature, but this will be in fact a long string, right, that contains the signature. So this prevents both attacks, because the user can no longer edit 17 into 18 and generate a valid signature. Okay, the signature verification will fail, Because if the user keeps the same signature, the signature is generated using a Hashian algorithms that guarantee that if you do make small changes to the original string, the same signature won't be valid. Moreover, the same cryptographic guarantee tells you that if the user makes a modification to the assigned string, which is delete 17, if the user makes a modification to it, there is no really good way the user can somehow guess the proper signature without knowing the signing key. And the signing key sits on the server. The user has no access to it. Okay? So the user no longer can modify the URL it received in order to do other things. Not only that, but in the other tab, the user cannot manufacture the proper signature, not even for delete 17. Okay? There is no way in which the user can add a signature here. Okay? It does not know how to do it. So this attack also is not possible. Because in the browser tab, there is no way for the user to know the proper signing key. So this application essentially obtained the signature from the server. Right? Because the server provided the original signed URL to that application. But this attacking application, does not have any way to obtain a similarly signed string. So also the second attack will not be carried out. So in general, when we develop Py4Web applications, we will be very careful to sign all the URLs that carry a user-specific effect, and all the URLs that provide the user with special information. Of course, on the server, when you receive a deletion request, you can still validate the request if you wish, but if the request carries a signature, you can be sure that it can at least not be forged by the user. It must have been a URL that you yourself provided to the user.